This is section 4.2. I'm going to go ahead and try to record. My internet went down in Sebastian, but I had Myopenmath open. The only thing is I can't check the answers because that would go back to the web and it would kick me out. So we'll hope that Mrs. H gets some right. Okay, so question 1. All right, they want us to look at this polynomial. I guess I should write it. And the questions are, first, the degree of this polynomial. You want to make sure you're in descending order, so highest exponent going down, and your degree will be the highest exponent when you're working with just one type of variable. So your degree is 9. They ask us to identify the constant term. The constant term is going to be negative 1/13. The leading coefficient is the coefficient on your degree term. So your leading coefficient is positive 9. And the leading term will be the 9x to the 9th. So pretty easy stuff. Just watch and make sure it is in descending order. For question 2, it's the same kind. Question 2 is not in descending order. So the main thing would be just change the order and put in descending order. And so the one with the highest exponent should go first. So 1/40, and make sure that you watch your signs when you're switching this. X to the 14th. And then you're going to go down. Since you can see both screens, I'm not going to write the whole thing. And I'm going to pause for 1 second and get my glasses so I can see these little tiny exponents. All right, so the degree of this term is going to be 14. The constant term is the one without a variable with it, so it's going to be 7/8. The leading coefficient is the coefficient of your term that has the degree on it, the highest coefficient, so the highest exponent. So the leading coefficient, I'm going to call that the LC, is 1/40. And the leading term is 1/40 x to the 14th. So that is problem 2 that was just out of order. I did pick problem 3. And they want us to match each of these with their correct graph. And so what you're going to be looking at is the end behavior. Hopefully you watched the other video that we have. And basically, first look at your degree, right? If your degree is even, it's basically going to look like some form of a W. Okay. And this might go way up, or it might not go up but a tiny bit, or it might even just be smooth like a parabola. If your degree is odd, it's like a cube graph. So it doesn't matter if it's 3, 5, or 7. It's going to look basically like this, and that one's not perfect. It's squished out, right? If you have a negative coefficient, so a negative leading coefficient, then it will flip it upside down. So my first one and I'm just going to put these up at the very top. So if it's even, it looks like a W. If it's odd, it looks like a cube. A negative leading coefficient will flip it upside down. So first one, and I'll write these. Right, so you want your degree. Right, it's even, so this one is going to look like a W. That's the first part of it, but it has a negative leading coefficient, so it's going to go upside down. So it's going to look something like that. And we can scroll through and look, it's not the first one. That one looks like a cube. Right, B looks right. B is the correct choice. Right, next one. And let me just pull this good so you can see the B, because it will come up with a different question when you have it. So this is the one, and it looks pretty much like an M, upside down W. All right, my next one if this was multiplied out, it would just be an x squared. You don't care about the other terms, so it is even. It's a degree 2. If you remember from last lesson, this one's a parabola. But degree 2 is going to make it look like this somewhat, but on a parabola, this piece is just flatter. Okay, but the ends still look the same, right? Your leading coefficient is a positive 1. So this one is not going to flip upside down. It's going to look like that W. Except there is no loop in here. So it is the parabola. So this one is choice C. Our next one, g of x equals negative 4 x cubed minus x squared. So you want your degree, which is 3. That's odd. So basically it's going to be a cube graph. except your leading coefficient is negative. So it's going to flip upside down. So it's going to go this way instead. So we'll look for that one, an upside down cube. Right? The first one looks like a cube, so it is not upside down. Here's your upside down one. Choice D. Right, and we had one more. Our j of x equals 6x cubed minus 6x squared plus 3x minus 5. And so your degree is 3. That's odd. Looks like a cube. It's a positive leading coefficient, so it does not turn upside down. So we'll look at our choices. A would be okay, because it could have shifted down. A it is. So, see, they don't all loop as much in there, but the ends are the same. And there is a table you can memorize. I just like to think of these two cases and then know to flip them or not. I think that's easier to remember. All right, so we're down to question 4. And so we just have one term here to look at. And they are asking us use the leading coefficient test to determine the end behavior of f. Well, it is even, so that is basically like a W. Our leading coefficient is negative, so that's going to make it turn upside down. So the graph of f, right, and they want rises or falls in these, right? So, and on one that's even, it will do the same. So this is our picture, so it's going to fall to the left and fall to the right. And I did pick 5. Same kind of question, but this one is one with odd. So we'll do one. Right, so we have h of z equals -7 z to the 7th. And our exponent there is odd, so that would make a cube. But our leading coefficient is negative, so that's going to make it turn upside down. So it's going to go like this. And to answer, you're going to say it rises to the left and it falls to the right. Then I skipped to 7. And we have s of x equals 8x cubed plus 10x to the 4th minus 1. And we want the degree of the polynomial. You have to watch out because this one's not in descending order. Your degree is going to be 4. Right. Leading coefficient will be the coefficient of that term. So our leading coefficient is 10. They want to know the end behavior, and they give us little pictures. And so for a 4, it would look like a W. That's even. And it's a positive leading coefficient, so it does not flip. So this is our basic picture. It's going to rise to the left and rise to the right. And that may seem a little weird for you for the left because you're used to looking at graphs from left to right, and you would think of this as declining. But when they talk about end behavior, they just want you to say it rises here. So it rises to the left and rises to the right. Then I did skip to number 9. So they're just giving you one that is not multiplied out. You don't have to multiply the whole thing, but you want to know your degree. So you've got x to the 7th times another x will be x to the 8th times another x will be x to the 9th. So your degree is going to be 9. So 7 plus 1 plus 1. Okay, give us 9. The leading coefficient is still going to be 1. And the end behavior. Well, x to the 7th is odd, so basically a cube. It's a positive 1, so it's not going to flip over. So it is going to fall to the left and rise to the right. And from your little pictures, you just look at your arrows. So it's falling to the left and rising to the right. It would be the first choice. All right, I did pick 10. And this is very important. It's just something that you need to know. There are 4 of the following terms are interpreted as exactly the same graphical feature. Select all 4. And they are talking about root. So 4 terms that mean the same on a graph. So they're talking about root, solution to f of x equals 0, X-intercept, and a 0. And that is the term that your graphing calculator will use to help you find the x-intercepts. So the places where the graph crosses the x-axis, that is what all of these are. Roots, solutions, x-intercepts, or zeros. And you can interchange those words. Right. Then they're going to talk about multiplicity. And this is how many times a root occurs in a problem. And the graph will act different according to how many times that root occurs. So we're looking at multiplicity. right? If R is a zero, so a root or a zero of even multiplicity, then the graph of f will touch and turn around at that point. On the other hand, if R is a zero of odd multiplicity, the graph will cross the x-axis. It will go through it. And that's all they want you to put in those boxes. All right, 12. So it says, given the graph of a degree 4 polynomial below, so this is our graph, complete the table of values, either the x value of a 0 or the multiplicity. All right, so our little table, and this is our root and the multiplicity. Picking it off from the picture. So the first one was the root is 5. And so we go look at our picture. And this is the one that's 5. It crosses through, so it is an odd multiplicity. The other thing here that we need is the degree is 4. And these will all add up to the degree. The multiplicities will. So we have 1, 2, and this one bounces, so that's going to be 2, 3, 4. So we're good. The reason I went back to point that out, because we just talked about even or odd. So if a root occurred 3 times, that's also odd, and it will look like this. But it would give you different answers here. Just at the end, you have to make sure you add them all up to 4 total. But we're going to be okay with the 3 separate ones because one of them will go 2 times. So it's not going like 5 or 3. This one is it's just odd. It's just going to be 1 this time. But watch out for that. All right. Next, they're telling us one that's multiplicity 2. So this is the one that's multiplicity 2, where it touches the graph, the x-axis, and it turns around. So at -5, that is an even multiplicity, and they already gave it to us, right? And we have one more 0 at -1, and it crosses through. So that is odd, and it will just be 1 because those add up to 4. Right, then I went to 14. G of x equals -5 times x plus 3 squared times x plus 11. So they didn't ask us degree, but we could get our degree. So this is 2, x squared times 1 more x. So our degree is 3. We'll just store that information. So they want us to determine the zeros of g of x and the multiplicity of each zero. So when you have factored form, you just set each one equal to 0, and you're not going to get a solution from this one because there's no variable. So x plus 3 equals 0. The x will be negative 3. This one, x plus 11 equals 0. X will be negative 11. Right? Your multiplicity is, this one occurs 2 times, which is even. So it's going to bounce. So this 0 has multiplicity 2. And sometimes I say bounce and sometimes I say touch and turn. I think most of the things in here say touch and turn. So this one is going to touch. It's not going to go through the graph. This one, it only occurs 1 time. So it is multiplicity 1. And it will cross the x-axis. And 2 plus 1 does give us 3, so we're good picking those. So they ask the multiplicity of the lesser root, all right? And so negative 11 is smaller. It would have to go in this box. And first you're saying x equals negative 11, and then you're saying the multiplicity. So for negative 11 is 1, and so lesser root x equals negative 11 is 1. Then they say the multiplicity of the greater root so the bigger one, which would be negative 3, that would go in your first box, is 2. And then down here you're going to answer whether it crosses or touches. So of the lesser root, x equals negative 11, the graph of g, and then you'll drop down and you will choose this one will cross, and this one will touch and turn. So next I picked 16. And this one doesn't give us factored form. And so we are going to factor here and set equal to 0 and solve. We have a GCF first of all, and our x cubed is a clue for that. Right, so we'll take out an x, and that leaves x squared plus 8x plus 16. And this is a trinomial, goes into 2 sets of parentheses, like signs both plus, and it's going to be 4 and 4. So these are just alike, so that's going to be considered a multiplicity 2. So we have x and we have x plus 4 squared. Right, and so they ask us the multiplicity of the lesser root. So first we have to find the roots. So you're going to set them equal to 0. Well, 0 is going to be the answer on this one. And it's only x, not x squared. So your multiplicity will be 1. And I'm going to drop on down here. And at this root, you know what? I have to be careful here because when I solve for the other one, x will be negative 4, and that is the lesser root. Okay, so I had to solve first, right? And this one will be multiplicity 2. So on your questions, your lesser root is x equals -4. Your multiplicity is 2, and it will touch and turn. And that would fill in the rest of the answers. The greater root, which is 0, has multiplicity 1, and it will cross. Right. I also picked 17 just to look at a couple different kinds of factoring and remember. This one is 4 terms, and you're going to factor that by grouping. So s of x equals x cubed plus x squared minus 36x minus 36. So we'll make 2 groups here. Here we'll take out a GCF, so x squared times x plus 1. Here, because it starts with a negative, take a negative out. And we can take a 36. That will leave x. Be careful here, you pull this negative out in front, so it leaves you a plus 1. And you want your parentheses to match when you're doing grouping, otherwise you're stuck. So we have x plus 1, and then you pick up these missing pieces. Also, this one will continue factoring. So this is going to give us x plus 6, x minus 6. So now we've factored, and you set each one equal to 0 and solve. These you could probably do in your head. X is going to equal -1, x will equal -6, x will equal +6. It's fine to go there if you feel comfortable. If not, you write your step, x plus 1 equals 0. That's what we're doing. Subtract your 1 from both sides. All right, and all of these occurred only one time. So we can answer in order now. I just wanted to remind you about the factoring of grouping here. So your least root will be -6, x equals. Your multiplicity of that root is 1. It only occurs one time, and it will cross. Right? The greatest root is 6. It only occurs one time, and it will cross. And the other root will be the -1. And it only occurs one time, so it will cross. So it's going to cross at all 3 of those. And I did pick 18. And they say, use the leading coefficient test to determine the end behavior of the graph. Then we will find the X-intercepts, or the zeros. Right, so end behavior. We need to know degree. It is 4. Leading coefficient is positive, so it's going to look like a W. So it is going to rise to the left and rise to the right. So it is your first choice. Next question says determine the X-intercepts. So we have to solve. So we're going to I'll just rewrite it since I had the other stuff written on it. So we have to do a GCF here. We can take out a 2x squared, and that will leave us x squared, and just divide, it goes 36 times. 2 into 72 goes 36 times, and we took the x squared outside. Right. This one will keep factoring. It gave you a difference of squares, x plus 6, x minus 6. And now we can solve. We'll set each one equal to 0 and solve. So this will be x equals 6. This will be x equals negative 6. This one you would divide by 2. It's still going to give you 0. And the answer is going to be 0, but this one is going to occur 2 times. So you have to be a little careful there. It is going to be x equals 0, but it occurs 2 times. Or the multiplicity is 2, which means the graph will touch it and turn around. All right, so all of our x-intercepts, 0, negative 6, and 6. That would be the answer here. And now they want us to describe each one. And they're asking us for multiplicity. Right, so the least 0 is x equals negative 6. It occurs 1 time, and it will cross. The greatest one is x equals negative 6. I'm sorry, that's the smallest. That's the smallest. X equals positive 6 is the greatest. It is also multiplicity 1, and it crosses. The other 0 is x equals 0. This is multiplicity 2, and it will touch and turn. And we'll see if they ask more. They did ask us a little bit more on this one. All right, so they have asked us for the y-intercept in xy form of this function. For y-intercept, you plug 0 into x. So we will write it. I just need a new page. 2x to the 4th minus 72 x squared. All right, so y-intercept says plug 0 in. And it's going to give you 0 back because you get 0 here. 0 times anything is 0. So the y-intercept is going to be 0, 0. We plugged 0 in. We got 0 out. That would be your answer here. This graph, if you remember back when we did odd and even, we had a shortcut, and if all the exponents are the same, so you don't have a mixture, like you don't have an x cubed in here too, then it's going to be even. So this one is, and then it's going to be whatever those exponents are, but they all have to be the same, odd or even. Okay, so these are all even. This is going to be an even graph, or an even function, which means it's going to be symmetric around the y-axis. right? And then they ask us, they're going to give us 4 graphs, and they ask us to choose the correct graph. All right, and at the beginning we said this one looks like a W. And it has a positive leading coefficient, so it doesn't flip over. So this one is a possibility. Actually, it's not going to be. It's a possibility because of the way it looks, but it doesn't have the zeros. Our zeros were 0. Let me put our zeros on here. Our zeros were 0, 6, and -6. And this one, it's going to touch and turn. The other two, it's going to cross. So that is actually going to rule out the first one, looking at the pictures. All right, it does go up on both ends, rises on both, but it touches at 0, but it doesn't have the other 2 zeros. So that one's out. This one is a possibility. It looks like a W. It touches at 0 and turns, and our other place is 6, and it crosses, -6, and it crosses. The second one is going to be our choice. Let's look at the other and see why we would rule this one out. This one's upside down. Even though it has the right zeros, it doesn't have a negative leading coefficient. And this one is upside down. So it is this second choice. Right, then I picked problem 23. So we have a polynomial of degree 5, has a leading coefficient of -1, a root of multiplicity 1 at x equals 2, so 2 had multiplicity 1, 0 had multiplicity 3, and 4 had multiplicity 1. All of these are odd, so it's going to cross at every one. All right, but that's not what it's asking us. Anyway, that's extra information. It's just free. Okay, so what they want us to do is to write the polynomial. So we're going backwards here. So your polynomial is going to have some coefficient here. That'll be your leading coefficient. And these are going to be your zeros. And basically it is x minus whatever your 0 is. So we'll call these k, or our roots. I think they do it like this. Root 1, x minus root 2, blah, blah, blah. Okay? So for our polynomial, on this one they gave us the leading coefficient. So this is a -1, or you can put just negative. All right? For your roots here, if we have 2, that came from x minus 2, because you would set x minus 2 equal to 0, and you would add, and so you get 2 from x minus 2. Right? You get 0 from a plane x. Right? So we're going to need an x out here with our negative 1. So I'm going to just scoot it over a little bit. And you don't have to write the 1. Right? And then a 4 comes from x minus 4. And that is our polynomial of least degree. You would not have to multiply it out. You could put that answer in. Right, let's look at 24. And the tricky thing on these last two is they do not give you the A. So you have to figure out the A. So they're giving us the picture. Says the graph of f below is complete. That means you're seeing all of it, that it's not out of your window. And that means you have the end behavior. So since it displays all zeros, the end behavior, and the y-intercept of the graph of f. Use the graph of f to answer the following questions. And it does tell us that all x and y intercepts are integers, which is helpful. All right, so looking at the graph, we want to pick the zeros with even multiplicity. Okay, so you have to watch. I mean, you can just look at your zeros. You have 2 zeros. You have -6 and you have -1. But they want you to answer the one with even multiplicity. That's the one that touches and turns. So zeros with even multiplicity is -1. And x equals -1 would come from, when we're going to have to factor it, it will come from x plus 1 will be the factor. Okay. So it touches and turns there. So that is an even multiplicity. Right? At -6, it crosses. Right? And let's see, if there's more than one of these, you would make a list. So we're good there. Right? With odd multiplicity, we have x equals -6. Because it crosses through, that's how we know that. So to get -6, that would come from x plus 6 equals 0. You would subtract the 6. And then they ask us to find the y-intercept. From your picture, it is -3. So as an ordered pair, that is 0 for x, -3 for y. And now they want us to give the factored form. They did tell us it's degree 3. So what we have, and what do we call this one? P of x or f? We call this one f. So f of x equals, we don't know the leading coefficient, right? We do know that it's going to be negative because this is a cube graph turned upside down. So it's going to be negative. But we'll go ahead and get that in our solution. So now we'll put the other factors, right? The one that occurs 2 times is this one. And this one occurs 1 time. Right, so that's a start. Now we have to find the A. And you find the A by plugging in the y-intercept. So the x is 0, so f of 0, and then remember f of x is y. So y here is negative 3. Negative 3 will equal, and in all of these we have to plug 0 in for the x. So this gives us 1 squared, which is 1, and 6. So we have negative 3 equals 1 times 6 is 6, times a is 6a. And you have one more step. You have to solve for a, so you're going to divide by 6. A equals reduce negative 1/2. So we go back on our function. So f of x equals negative 1/2 x plus 1 squared and x plus 6. This would be our final answer on that one for our polynomial. All right, so I picked one more question. $25, and you're going to do the same kind of thing, right? And so this one is also going to have a negative leading coefficient, and I know that because it's like an upside down cube. So upside down makes it negative, okay, the leading coefficient. All right, so here's our graph, and we will need to pick off the zeros. So we have 1, x equals 1. We have 3, and we have 7. For all of these, it crosses through. So these are each going to just occur one time. I'm assuming it's a degree 3, and we have the whole graph. Maybe they told us, yes, they told us that at the end. So we have all the zeros here. So this comes from x minus 1, x minus 3, x minus 7, and we'll have some constant here, or some for our coefficient, and we'll call this one f, I think. All right, and so when you answer these, you have to just watch when you read it. Even multiplicity, none of these have even multiplicity. They all occur one time. So you're going to say no on that one. None of them have even. They all have odd, so you would answer 1, 3, and 7 here with comma in between. The Y-intercept, so I'm going to have to go back to the graph, and then they want factored form. The Y-intercept looks like 3. And the x is 0. Right, so we have f of x equals a times x minus 1, x minus 3, x minus 7. We're going to plug in f of 0, and then this will equal 3 because this is really y. So we're plugging in 0 into all the x's. So we have 3 equals a times negative 1 times negative 3 times negative 7. And so we'll multiply these out. So this would give us positive 3 times a negative 7 will give us a negative 21. A equals 3. Divide by negative 21. And you'll need to reduce here as a common factor of 3. So a will equal negative 1/7. So our function is -1/7 times x minus 1 times x minus 3 times x minus 7. And we'll stop there on this lesson.